Hello and welcome to the Section 4.4 application walkthrough. I apologize that these are a little bit difficult to read. We'll do the best we can. It's because of the print quality that it kind of gives us a little glare on these other problems here. But let's go ahead and look at the first one for right now because it is an interesting problem. Now we talked about similar figures in this section, and I'm going to go ahead and match up sides and put them over each other. So I have x over 2x equals 4 over 8. And I want to look at what happens on this problem. Let's say that we cross multiply or use cross products here. So I have 8x equals 4 times 2x. Well, that turns into 8x as well. And let's say that we go and subtract 8x from both sides. We're left with 0 equals 0. Okay, if you remember back to the solving equations days, that's a true statement. So we have infinitely many solutions. Okay, infinitely many solutions there. Any numbers for x will make those proportions true. So that's kind of a neat problem, but definitely, not always the nicest problem to look at. So still important now. Let's go and look at number 3. Number 2, I think will turn out a little bit different. It looks like you're going to get just one solid answer for that. Just make sure that you know how you're setting it up. Make sure you go either big triangle to little triangle or little to big. Don't be using just these numbers here and here. Make sure that you know that the entire this side is that entire length for the big triangle. Okay, so go ahead and get that problem done. On number 3, says Nina was curious about the height of the Eiffel Tower. She used a 1.2 meter model of the tower and measured the shadow at 2 p.m. Excuse me. The length of the shadow was 0.9 meters. And then she measured the Eiffel Tower's shadow, and it was 240 meters. What is the height of the Eiffel Tower? We just have two similar triangles here, so don't let the fancy talk fool you. You're really just looking at, let's say we match up these sides. We'll go scale to the actual. 0.9, we're talking about the shadow first, to 240 equals scale 1.2 to x on the actual. Okay, and so solving that proportion, you can easily figure that one out. And let's go and look at the last one. So Greek mathematician Thales was the first to measure the height of a pyramid by using geometry. He showed that the ratio of the pyramid to a staff was equal to the ratio of one shadow to the other. If a pace is about 3 feet, approximately how tall is the pyramid at this time? Okay, so it shows paces here, and you want to look at turning paces into feet, okay, because they didn't really use feet that much. They just used how much they could walk. So you just want to set up your ratios correctly and keep in mind what you're looking for. You're looking for the height of the pyramid. So you want height pyramid so height of the pyramid over, let's say, shadow of the pyramid, or yeah, we can use shadow of the pyramid. Equals height of the staff over shadow of staff. Okay, And once you plug in all those numbers where they need to go, you can easily solve the ratio for what it needs to be. But step one does need to be turn paces to feet. Okay, so that's step one. Step two is solve that ratio, or solve that proportion. Sorry. So after that, you guys should be good to go. And make sure you get that master challenge done. And good luck on the test that's coming up. I think you guys are more than ready for it because you breeze through this. Just keep up the good work, and this will be the last test in the first units, or in the first term. That's pretty good. Get that credit done. Talk to you later.